Hey guys, what's up? We're going to look at the three states of matter. So we've got three diagrams here, and these represent the three states of matter that you need to know about. So the first one is solids. The second one is known as liquids, and the third state of matter is known as gases. Okay, and we can change between these, and we call those changes the changes of state. So if you take a solid and you turn it into a liquid, that process is known as melting, as I'm sure you're aware of. If you take a liquid and turn it into a gas, that's known as boiling. It's also sometimes called vaporization, and evaporation is that process that happens but at a temperature lower than the boiling point. If you take a gas and turn it into a liquid via cooling it, we call that condensation. And if you take a liquid and you freeze it into a solid, that process is known as freezing. There is another change of state, which is where a certain solids can turn straight from a solid to a gas without going through the liquid phase. Carbon dioxide does this. It's also known as dry ice. It turns from solid carbon dioxide into gaseous carbon dioxide without going through the liquid phase. And we call that process sublimation. So we need to now know about the properties of these states of matter. And the way we do that is by using the particle model. And if you understand the particle model, you can understand the properties of solids, liquids, and gases. So let's look at solids first of all. So the particle spacing is very tight. All the particles are as close as they can possibly get. The particle motion is that the particles just vibrate about a fixed position. They can't move. So they vibrate about a fixed position. That's really important because it's very different to the particle motion in liquids and in gases. The intermolecular forces, what I mean by this is how well the particles attract each other, the strength of that force of attraction between the particles. And in a solid, you can see the particles are very close together, and that's because the intermolecular forces are very strong. They're held tightly towards each other. They attract each other really well. The particle kinetic energy, however, is low. The particles can't move, they just vibrate about a fixed position, and that's because their kinetic energy, the amount of movement energy they have, is actually pretty low. Solids, as you know, they're not fluid, they can't flow. And the reason for that is because the particles are in a fixed position and they have low kinetic energy and very strong intermolecular forces. So the particles cannot flow past each other. Another property about solids is that they're incompressible. If you take a lump of wood or iron and you try and squash it and reduce its volume, you can't do that. And that's because there's no free space between the particles. When you compress something, you're bringing those particles closer together, but in a solid, they're as tightly packed as they could possibly be. They simply can't reduce the space between them. There is no free space to reduce. So secondly, let's look at liquids. The particle spacing here is still tight. There is a tiny little bit more space than in solids, but when you draw it, you have to draw it as I've drawn here with just only a little bit more spacing between the particles. The particle motion here is very different though compared to solids. The particles are actually able to move past each other. So I'm drawing a few arrows on my diagram. So the particles can move past each other. This is because the intermolecular forces in liquids, the forces between the particles is I'm going to call it medium. It's not as strong as in solids, but it's actually stronger than in gases. Because these particles are able to move, they must have more kinetic energy, because kinetic energy is just a measure of how quickly these particles are moving. So I'm going to say that the kinetic energy is medium. They've got much more kinetic energy, the particles do, compared to in the solid phase. So liquids, if you think of water or if you think of alcohol or any other fluid, we know that it can flow. And that's because the particles, as we've seen, are able to move past each other whilst maintaining this tight particle spacing. Many people think that liquids are actually compressible because they can change shape. Liquids can flow and they can fit the shape of a container. If you squeeze a bottle of water, it looks as if that water is being compressed. But by compressibility, we're talking about, can you reduce the volume? If you have a liter of water, you can't reduce that volume by compressing it. So liquids are not compressible, and that's because there is not enough space between the particles that could be reduced when you're moving those particles closer together. We've said that the particle spacing is tight, and we simply can't force those particles to be any closer together. Now, finally, gases, the third state of matter. They have a wide particle spacing. The particles, as you can see in my diagram, they're represented as being far apart. The particle motion is very different into liquids and solids. The particles are able to move rapidly and randomly. They're actually able to move freely as well. So you can see that they're just moving in any direction, and they have a range of speeds and a range of kinetic energies. A reason for this is because the intermolecular forces, those forces between those particles, is very weak. The particles do not attract each other very much, so they're able to just move as freely as they like. The particle kinetic energy in this case is very high. And that's because gases are at high temperature, and high temperature means that the particles have a high average kinetic energy. Gases are also known as a fluid, just like liquids, and they're able to flow. So if you think of any sort of gas, if you had a gas that you're using in an experiment, the gas is able to flow freely through pipes, through tubes. So they are able to flow. And that's because the particles have such high kinetic energy and the intermolecular forces between those particles are weak. So these particles are able to flow and fit the shape of the container. Gases are the only state of matter that are compressible. And when you compress a gas, you're bringing these particles closer together and you're reducing the spacing. So there we have it. The three states of matter: solids, liquids, and gases. You need to remember the changes of state, and you need to be able to explain the properties by referring to the particle spacing, the particle motion, the intermolecular forces, and the kinetic energy. That's it. Thanks for listening. See you all soon.